So for our lesson 3, now we are going to discuss the Ohm's law and its relations. So its statement says that the current drawn by an electrical load is directly proportional to the voltage across the load and inversely proportional to the electrical resistance of the load. Therefore, current is equal to voltage or the electromotive force divided by the resistance. Okay, so if we are going to derive equations and relations to this Ohm's law in terms, um, in relation with power, so we can have here. So power would be equal to voltage times current, and this is also equal to current, the square of the current times resistance. So using this equation, you can derive two other equations. And then power is also equal to voltage, the square of voltage, and then divided by the resistance. So again, how did we get this kind of equation? These are just taken here. So all you need to do is just substitute this one here, or vice versa. So now let us go into discuss the series DC circuit. Okay, the series DC circuit, we know that its resistance relation. So assuming in our figure we have three loads or three resistances, this will serve as our resistance. This is our load. Our load is like smartphone, electric fan, so do not forget that. So the resistance relation, um, it says here that the total resistance, or the R equivalent or Req, is equal to the sum of the resistances of each resistor. So we have three resistors. To solve for the total resistance or the R equivalent for this circuit, just R sub 1 is R sub 2, R sub 3. Yeah. So about the current relation, the total current that flows here, so from negative to positive, the total current is equal to the current flowing in each resistor. So we could say that, assuming if we have our if our total current, the total current is equal to the current flowing in each resistor. So if we have a total current of 2 ampere, the current that flows in R sub 3 is also 2 ampere. And then the same with R sub 2 and R sub 1, 2 ampere. So that is the current relation in series DC circuit. So for our voltage relation, it says here that the total or supply voltage, or the VEQ, is equal to the sum of the voltages across each resistor. So if we have a voltage here, this is our VEQ, the voltage for R sub 1, the voltage for our R sub 2, then the voltage of our R sub 3 must be equal to the total voltage. Therefore, the voltage here will be equally divided by our three resistors. So that is for the series DC circuit. Next is the parallel DC circuit. Again, we have still three resistances, or we have three loads: R sub 1, R sub 2, and R sub 3. And here is the VEQ. So what would be the resistance relation? The reciprocal of the total resistance Req is equal to the reciprocal of the total resistances of each resistor. So we have R1 over Req equals 1 over R sub 1 plus 1 over R sub 2, 1 over R sub 3. So if you are going to derive this one to solve for easy to calculate, so we have Req this would be equal to 1 over 1 over r sub 1 plus a 1 over r sub 2 and then 1 over r sub 3. So you so this is just the same answer if you're going to solve for the REQ. So the current relation for this one, it says here that the total current REQ is equal to the sum of current flowing in each resistor. So I sub 1 plus I sub 2 plus I sub 3. We can say that if the total current will flows here, so the total current will be equally divided by each resistor. So different in R sub 1 divided also. So they have so this is our equation. So next is the voltage relation. The voltage relation is it says here that the total voltage or VEQ is equal to the voltages across each resistor. So that is so if we have the voltage equivalent here, let's say we have 2 volt, the same with the voltage across the R sub 1, the same also with R sub 2, 2 volts, and then the same also with R sub 3. So you need to understand, you need to formulate or to memorize or to know the concepts or the basic concept or the equations involved in relations with current, voltage, and resistance for a series and parallel circuit. Now we have an example here. For our example number 6, or our first example in this topic, we're going to determine the following quantities for each of 2 circuits shown below. So we have given circuits here. We have a series circuit and then we have a parallel circuit. So we are going to identify the equivalent resistance or the total resistance, the current drawn from the power supply, or this is the total current or the equivalent current, and then the current through each resistor, and then the voltage drop across each resistor and the power dissipated in each resistor. So here is the series circuit. So we have 3 loads or 3 resistances. We have 20 ohms, 30 ohms, 50 ohms. So they are the first resistance, second, and third. So we have total voltage or power supply 125 volts. And then for ours parallel circuit, we have just the same givens or the same loads, 20. No, they are different. So we have 125 volts. Our R sub 1 will be 20 ohms, and then our second load or resistance is 100 ohms, and then our last resistance is 50 ohms. So now we are going to solve for this one. So first, let us go to solve for the series circuit. So in solving this series circuit, so just follow the rules or the relationship between the current relations, the resistance relations, and the voltage relations. So just use that one that we have discussed earlier. So first is let us going to discuss the resistances. So we know that in order to solve for the resistance in the series circuit, we know that we are just going to add up all the resistances. So to solve for the R equivalent or the total resistance, so R sub 1 plus R sub 2 and then R sub 3. So we are going to calculate 20 plus 30 and then plus 50. This will derive the answer 100 ohms. And then we know that in series circuit, as a reminder that the current is constant, or the current flow from the power supply or the total voltage is just equal to the current that will flow in all for each resistances. So The total current is determined by the voltage of the power supply and the equivalent resistance of the circuit. So yes, we could say that the total power will be equal to the voltage total divided by the resistance, the total resistance, or the R equivalent. So here we already have the V equivalent, or the total voltage, which is 125, and then we already calculated a while ago the total resistance in series circuit, which is 100 ohms. So we can easily calculate the total current, or the I equivalent, or the current that flows here. This is equal to 1.25 ampere. So we know that this is the total current, and then since the current is constant through each resistor, since we are in series, so if in this circuit, if we have here if the current that flows here is a 1.25 ampere, so the same also for the current that flows here. This is also equal to, this is our IEQ. So the same also current that flows here, and then the same also the current that will flow here. So they are just constant. So they are just equal to the I total, which is 1.25. Okay. So next is to solve for the voltage drop in each resistor. So we know that the formula for voltage is is equal to the product of current times the resistance. So to solve for the voltage drop across the voltage drop for the first resistor, or R sub 1, we need the current for the current of I sub 1. So since here, so this is I sub 1. The current that flows here is I sub 1, I sub 2, I sub 3, and we know that the current, they are just the same, they are just equal to 1.25, so no need to worry. So here it is. So voltage V sub 1 will be equal to the current for I sub 1, and then the resistance for for our R sub 1. So V sub 1, we know that the current for I sub 1 is 1.25, and then our R sub 1 is 20, so just multiply, so we can get we will have this one, so we can get 25 volts. So this 25 volts V1, this is the voltage drop here. So this is V1. So here is the V1. Okay, and then for our second voltage, to find V sub 2, just using the formula for the voltage, we are going to multiply the I sub 2 and then times the R sub 2, and then we know that the I sub 2 is just the same with the total current, which is 1.25. Just multiply to the resistance, the second resistance, which is equal to 30 ohms, so we can get that the V sub 2 is equal to 37.25. So this is the voltage drop. So the voltage drop, so 37.5. So the voltage drop here is 37.5. So 37.5. So next is to solve for the V sub 3, or the voltage across, the voltage drop in the R sub 3. So again, same formula, just we are using the the current that flows in the R sub 3 and the value of the R sub 3 in resistance or in ohms. So again, I sub 3 is just equal to 1.25, and then our R sub 3 is equal to 50 ohms. Just multiply, V sub 3 here is equal to 62.5 volts. So this is already the voltage drop across the R sub 3. So 62.5. 62.5. See 62.5. 62.5 volts. Here it is. So if you are going to check or if you are going to verify your answer, if all of the three voltages is equal to the total power supply, so just VEQ, just compute VEQ, just use this equation. VEQ is equal to V sub 1 plus V sub 2 and then V sub 3. So VEQ is equal to 125 volts, and then our V sub 1 is equal to 25 volts. Our V sub 2 is equal to 37.5, and then our V sub 3 is equal to 62.5. And then if we're going to sum up these voltages from V sub 1 to V sub 3, we can calculate that it is equal to 125. So if you observe they are just equal, so we could say that your voltages, the computed voltages that you had done earlier, is checked. So last one is to solve for the power dissipated across each resistor. So they consume power. So what would it be? So just using the formula for the power, power will be equal to I times voltage, or I times E, or also you can use the I squared times R, and then so on. So just it depends on your idea on how are you going to solve. So for me, I think the easiest one to solve is using this formula. Power is equals to current times voltage, because you are just going to use simple multiplication. So to solve for P sub 1, or the power dissipated in our resistor, our first resistor or our first resistance, so we are the problem asks if what would be the power dissipated here. So so here is P sub 1 is equal to 25, because voltage sub 1 is 25 volts. I sub 1 is 1.25. So just simple multiplication, P sub 1 is equal to 31.250 watts. So this is the power dissipated in R sub 1. Okay, so P sub 2, this is I sub 2 times R sub 2. So I know in this problem I use what do you call this, numerous kinds of solutions or equations, so that all equations that we have discussed in the previous a while ago will be used here. So P sub 2, so we will use the equation P power is equals to I squared. So power is equals to I squared times R. Yeah, so here we know that our current is 1.25, so this is raised to 2. This is raised to 2. I squared, we use this one. So we know that our current is I sub 1.25 ampere, and then our R sub 2 is 30 ohms. So just use your calculator. 1.25 raised to 2 times 30, this will result into 46.825 watts. So this is the power that will dissipate in our R sub 2. Now, for our last power dissipated for our R sub 3, we will use the formula power is equals to the square of voltage divided by the resistance. So here we know that the voltage for R sub 3 is 62.5. So we will use that one. So 62.5 raised to 2 divided by 50. So we get the power is equal to 78.125 ohms. So this is the power dissipated in R sub 3. So this is how easy to solve a circuit, a particular circuit in series. So that's all. Now to continue our discussion in solving the parallel circuit. So again, the same technique or the same step that we're going to solve for this circuit. Again, just follow the rules or the relations of voltages, resistances, or the current that will be involved here. So first is to solve for resistances in a parallel connection. So as stated in the in its relation that the reciprocal of the total or the R equivalent is the sum of the reciprocal for all resistances. So or you can use this equation, or you can also use this one. The Req is equal to 1 over R sub 1 plus 1 over R sub 2 plus 1 over R sub 3. Yes. So you can either use this one or this one. So it depends on your solution. So just substitute of if you use this one, you can directly substitute. And then we know that R sub 1 is 20 ohms, R sub 2 is 100 ohms, R sub 3 is 50 ohms. So or you can use this one, that's okay. You will just have you can just derive the same answer. So overall, if you are going to use your calculator, our R equivalent will be equal to 12.5 ohms. So next is to solve for the total current. Total current. The total current is determined by the voltage of the power supply and the equivalent resistance of the circuit. So current, based on the current relation, current is equal to, based in Ohm's law, current is equal to voltage divided by the resistance. And we know that again, as a reminder, that in parallel circuit, we know that the voltage is constant. The voltage 1 is just equal to the voltage 2 equal to voltage 3, and then it is also equal to the voltage equivalent or the total voltage or the voltage in the power supply. So to solve for the IEQ, 125 volts divided by, so the VEQ or the total voltage divided by the total resistance. Next, so our I equivalent now is equal to 10 ampere. So this is the current that flows here. So this is the IEQ. The current that flows here is equals to IEQ. Yan. So next step is to solve for the current in each branch. Okay, we will be using the Ohm's law. So I sub 1 is equal to V sub 1 divided by the R sub 1. And we know that the voltages in parallel circuit are just constant. So if the power supply, since the power supply has 125 volts, or this is the V equivalent, this is also the same with the V sub 1, V sub 2, and V sub 3. So using the Ohm's law, I sub 1 will be equal to V sub 1 divided by R sub 1. So therefore, I sub 1 here is equal to 6.25 amperes. To solve for the I sub 2, the same formula, just substitute 125 divided by 100. So we have I sub 2 is equal to 1.25. Then to solve for I sub 3, the same formula, V sub 3 divided by R sub 3. We have 1.25 as our V sub 3, and then our R sub 3 is equal to 50 ohms. So our I sub 3 is equal to 2.5. So that is the current. So this is the current that flows in R sub 3. This is also the current that flows in R sub 2, and this is also the current that flows in R sub 1. So if you're going to verify your answer, just add all the currents for each resistances and compare it to the total current. And you must observe that the total current must be equal also for the summation of all current in each resistance. So here we have 10 ampere equals to our I sub 1 is 6.25 ampere, I sub 2 is equal to 1.25 ampere, and then I sub 3 is equal to 2.5 ampere. So if you're going to add up all this one, we can have a 10 amperes. So check. Therefore, our solution is correct. So our next quantity to be solved is to solve for the voltages for each branch, the voltage drop for each resistor or resistance. So again, they are just equal, constant. V sub total or V sub EQ or equivalent voltage is equal to V sub 1 equal to V sub 2 equal to V sub 3, and then also equal to 1.25 volts. So again, as an exercise, use a different equation to determine the electric power of the resistor. So we will be using power is equal to I times voltage, also equal to the square of current times resistor. And then we will be using also the equation V squared divided by the resistor to measure our knowledge. So first step, let's solve for the power dissipated at R sub 1. So the same formula, we will use this equation. P sub 1 is equal to V sub 1 times I sub 1, or current times voltage. We know that our voltage is 1.25 and our current is 6.25. This is equal to 781.25 watts. So this is the power dissipated at R sub 1. To solve for P sub 2, or the power dissipated in R sub 2, we get from using the equation, so our second equation, I squared plus R. So since our current is 1.25 square times 100. So anyway, you can use also V sub 2 times I sub 2. So there you can get the same answer. So 1.25 squared times 100 is equal to 156.25 watts. So this is the power dissipated in R sub 2. So last to solve is the power dissipated in R sub 3. So V sub 3 squared divided by R sub 3, or we will go to use the latter equation. So, or you can also use this one, as long as you will be involving only voltages, currents, or resistances in R sub 3. So V sub 3 is equal to 125 divided by the R sub 3, which is 50 ohms. So therefore, our P sub 3, using your calculator, we can have 312.50 watts power dissipated at R sub 3. So the only thing that you must remember to solve for this kind of problem in circuit, series and then parallel circuit, first is you are going to know the concept that if it is series in this equation, if the circuit is in series, we know that all currents are equal, and then if the circuit is parallel, the voltages are equal, and so on. And then if you are going to solve for the current for R sub 1, you will use also all the quantities that involves in I sub 1. So you are going to use the R sub 1, V sub 1. So you must not use the R sub 2, V sub 2. So if the equation, if you are going to solve for I sub 1, you will use all the quantities that involves in I sub 1. If in I sub 2 or in this resistance, which is 30 ohms, or in I sub 2, use all the quantities that involves here. So you are not going to use the quantities here and then here, so you will derive a different answer. So that's all. So thank you.